Yeah, it's coming. Yeah,
Uh, okay. So now this is what I have copied these slides from previous session. Okay.
yeah.
So firstly, the introduction part, no, like he has they taken complete class in telling the in fact introducing what is this complete deep learning is about. Okay, so you might be aware of deep learning, but I am new to the subject in the sense the being in forces, we have not been dealing with it quite regularly or oftenly. So now in deep learning, he says it's an extension of the machine learning. Okay, so what he says is there are three things he first compares. One is the handcrafted one. The second one is machine learning, and the third one is deep learning. So he says, if why are we progressing? Why we need deep learning? Why not till machine learning? If anybody asks, what is the need of deep learning?
Yeah,
So
it's what I learned is that in the ML we have only one level of hidden layer. In deep learning we have several layers to exactly find the trend of the input data.
yeah, like he has told very clearly and very categorically. Like first we see the handcrafted one. In the handcrafted one, like suppose we use Java or any other language. So we design oblique extract the features
Hmm.
and we also write the functions that extract those particular features, and then we get the output. That is a completely handcrafted one. In machine learning, what we do, that features are there we extract or we get the features, and we use certain already defined algorithms to get the output, like any algorithm, SVM, or any other any other logistic or linear regression, any algorithm we use to get the output. And in deep learning, what he says that the features which are extracted, it's also automatic, and the algorithm which is applied with their various algorithm, of course. So the main part which is there, like the feature extraction, the feature extraction is very much automated, or it is said that it is evolved in deep learning. Now, what is feature extraction? Like, suppose we got a table of all those people who have studied various subjects and they want different admissions in different universities. So every column has a relation with each other. Now, if you like, we did our machine learning assignments also. So what we did, we tried to find out the relation or correlation, covariance between the various columns, or the we tried to first find out the predictable and non-predictable variables, and those based on the predictable variables we were able to predict something. Okay, now deep learning, what it does, it automatically defines and extracts the relationship between the various variables, and those variables feature extraction is so efficient, so perfect, that
Your voice is
it's
breaking.
quite good. In fact, is it not audible?
Yeah, sometimes it's breaking.
Yeah, yeah. I am presently in Udhampur. The weather is quite pretty bad here.
Okay. Now it's okay.
If I something is missing in between, just let me know. I'll repeat it once. Huh?
Okay.
Hmm. So what we were there, like feature extraction in deep learning. So in
Yeah.
deep learning, what happens? The feature extraction is very efficient, and it's based on very high dimension. Like in machine learning, we have seen if you take more dimensions. So our model will be not accurate, or accuracy will be affected because of the high dimensionality. But in deep learning, the efficiency and higher dimensions all are taken care of, and we get a better representation. So that is why we go for the deep learning. Okay. And then he says, for a particular session, he has been following this Mukesh Kapila of IIT Madras. He has been taking this slides from his lectures. So I tried searching in NPTEL, there is a Mukesh Kapila lectures are there for deep learning.
Okay.
Okay. So far it's so clear why we are going for deep learning, huh?
Yeah.
Okay.
The feature extraction, right? Which features are important? That's the point, right?
Yeah. See, in feature extraction, it is just not the only importance of features. It is like what is the relationship? Suppose that same Andrew Ng's problem, wherein he talks about the prediction of house cost based on where it is located and all those factors, no? Size of the house. You have gone through that Andrew Ng's problem, no?
Not exactly.
In the Stanford University, like what Professor Manali has taught about linear regression, logistic regression, um, if you just go on YouTube, just type Andrew NG, you will get his lectures of Stanford University, and they are really good. What Monali has tried to teach us, he has solved it in a very, very professional manner, and in fact, very much understandable. So what Andrew NG does, he takes an example wherein he says in Manhattan, he wants to predict the house cost. Okay, so he takes features like the size of the house, where it is located.
Yeah,
Okay,
that
and he
some
takes only
parameters like room, number of rooms, and right,
correctly,
mm,
correctly.
square feet.
So yeah. So now this is like he has, out of so many parameters, he has taken two, three parameters. Okay.
Yeah.
Or we can say it's not the parameters, it is the variables, characteristics. And now the deep learning, what it does, key, it defines the relationship between these variables. And that relationship, oblique, the study of that relationship is so accurate that it is able to predict the cost of house in a much more better way.
So it will in deep
Okay.
learning we need not give that which features are important. We need not do it manually. It will find it automatically or something, right?
Exactly. What Professor Chandrasekhar was saying that we give the complete table as a table or data as an input to the deep learning system. Okay, so deep learning, then it will decide in deep learning, like what output we want. That has to be first identified. Based on the output, we just give the complete data. It learns on its own, and it gives the output. Okay, like in neural network, you must be aware of MLP. This is multi-layered perceptron. है ना? This is the basic thing which we did in our machine learning. Now,
This it's
yeah,
having a one input layer, one hidden layer, and one output layer like that, right?
it was the basis was one input, one hidden, and one output. But once we in the hidden layer, we can have many layers of perceptron. Okay, so multi-layered means what it was doing exactly is that in the exam also, what problem we had use sigmoid function to basically classify the output, if you remember.
Yeah.
So we have done the simple classification problem. But what happens? uh, when in the classification, there is another kind of algorithm, or you can say neural network, that is called as convolution network, neural network. Okay.
Okay. Did we study that in the SEM 2?
No, no, we didn't study convolution and we
Yeah.
didn't study RNN also.
Mm-hmm.
Okay. So basically, what Professor Chandrasekhar told, that MLP and CNN both are for the classification.
Mm-hmm.
Okay. But convolution, how it differs, I'll just share my screen. Uh, okay. So, if I'm just going through what I use three-dimensional data for image classification and object recognition task.
Mm-hmm.
Okay, like suppose we
Uh,
have
just a question. This CNN thing is coming on which chapter? I think it's in
uh,
advanced chapter, right?
huh, it's like what he was giving, like he was giving the examples
Ah, okay. Just an
of
overview of the.
neural networks we have, uh, and just an overview what we are going to study in deep learning.
Okay.
Okay, so in deep learning, if I just go to this slide, I'll come. Yeah, here it is. Can you see the slide?
Yeah. Yeah.
Yeah. So in this, the first is the multi-layer perceptron, which we have studied. Then convolutional and recurrent neural networks. So for the classification, all these three types of neural networks are there. Okay. But he says MLP is good for when we have got no time bound data, or in fact, when data is not very real time basis, and it is not that very frequent data is we are not getting. Okay, but once the data is very frequent, very like suppose the bus is moving from say Delhi to Goa, and after every few fractions of second, we get the image of that bus, and we want to see how the bus has gone from this place to that place, and we want to do the classification. So that real time frame data which we are getting cannot be handled by multi-layer perceptron only. There we have to go for the convolutional network. Okay, so this is one he wants to he was giving examples. One other good thing is recurrent networks. Recurrent networks are really better ones. In this, what happens? Like uh, suppose their outputs in multi-layered and convolution networks, uh, each layer has got different weight and bias. Okay, so those weight and bias are based on they are independent. They are not dependent on each other. The thing is that in the what we feed forward type of system, the previous layer of network gives a feed to the forward layer, and using the back propagation, we are able to do this, define the error and reduce the error using gradient descent, and that is how we learn the weights and bias. This is what we learned in MLP.
Uh, let's say MLP is like a feed forward something, right?
Yeah, yeah. See, feed forward is just for giving like input from the previous layer to the output, next layer. But how do you calculate the error? The error
Yeah.
is calculated. In fact, how we started the error calculation, we went to the last layer, the output layer. In the output layer, we compared what is the predicted value and what is the actual value. Y hat and Y we compared, and we got an error. So we wanted to reduce that error.
Mm-hmm.
So for reducing that error feedback was given to the backward layer.
Mm-hmm.
And similarly, this complete feed forward network for error calculation and gradient descent, it became the back. Um, what do you say? What is the name given to it?
You mean the
Back propagation. Yeah.
weights and bias are changed according to the dose, right? That one?
Mhm. Yeah. In fact, see, in linear logistics, any regression, wherever we have to minimize the error, everywhere it was like we minimize the error
Mm.
and then change the weight and biases. That is the machine learning basic concept.
Yeah.
Okay. So in neural network also, we minimize the error and we change the weight and biases of each and every layers.
Mm.
Okay. So that is how the multi-layered perceptron worked. Huh?
Mm-hmm.
Okay. But in the recurrent, what happens that every layer, instead of having a different weight and bias, they have a same weight and bias.
Mm-hmm.
The hidden layers, suppose there are one layer, two layer, and three layers.
Mm.
Okay.
Mm. Yeah.
That first layer is having W1, B1 as the bias and the weight. Second layer, W2 and B2. And third layer has W3, B3.
Mm-hmm.
So in recurrent networks, what happens? He all these weights and biases are same for each layer. So
Mm-hmm.
these layers are combined, and then it forms a recurrent kind of layers. That is why it is called as recurrent networks.
Mm-hmm.
Understood?
Yeah. So it's like, so it is like MLP but with the weights and bias same. Huh?
Yes, yes, very true. In RNN, like recurrent, why the name recurrent is given? Because the weights, biases, and the network, everything is recurring.
Mm-hmm.
See, because same, like first I have selected a model wherein weights and biases were different. Then I have made it same.
Mm.
So repeating, it is recurring. The layers are recurring. That's why it is the name has been given recurrent networks.
Mm-hmm.
And these recurrent networks, neural networks, are used for the temporal data. Means very like if we are getting continuous supply of data every second or every fraction of seconds, then it is used. And it was like RNN has a type of memory also, small. This I could not understand, but probably we may understand it in better this thing. Okay.
Mm-hmm.
So, what we are going to study, we are going to study the MLP,
Mm-hmm.
convolution networks also, and the RNN also.
Mm-hmm.
Okay, this RNN will be utilized for you can you see nowadays, na, like in LinkedIn, all where there is a video like tagging of various features, human, car, building, everything in the real time frame.
What is it?
I'll just show you what how it is.
Mm-hmm.
Uh, like this image recognition.
Oh, image recognition. Okay. Mm-hmm.
Okay,
Mm-hmm.
this is image segmentation and recognition.
Mm-hmm. Okay.
Okay,
Mm-hmm.
this is by using RNN.
Mm-hmm.
Okay, so uh, like what uh, in this particular slides he is trying to say why we are using deep learning networks. Huh?
Mm-hmm.
So this is the objective of this course, where is we are understanding the neural networks, comprehending the models so that do the previously mentioned task, and design build train networks for various tasks. So he said ki, like we choose output, what kind of output we want. Based on that, we design the model of neural network we want to use.
Understanding
Hmm.
neural network, comprehending the model that do the previously mentioned tasks, and ways to become expert in one course.
He's just uh, so he said the concept is more important. Then we'll see the something practical this thing also. Uh, Implement various neural network architectures. Now this is the way. This is what we are going to see. Uh, we have just seen multi-layered perceptron, convolution network, and recurrent network. Now there is two more models, that is generative. Both these are generatives. That is the generative and adversarial models. Okay. I was just going through on the net, but I could not understand much of it. Probably we have to concentrate in the class. Generative, I could get only that generative models are those which generate features, like all those features which are not there, but based on some values they generate features and then predict it. So the time series analysis which we have seen in statistics, that can be done by using these generative models. And in fact, these generative models will be used for replica of anything. Like we want to create somebody's voice, we want to create somebody's picture or something like that. All these generative models will be used. So this is also we are going to study. Okay, so this is just the applications what we are going through. Using generative languages and computer vision using recognitive techniques. He said the primary book is that Goodfellow. In fact, I purchased this book. Quite a nice book. Okay, this is all logistics. He was okay with it. He just kept. Okay, so he said in this particular, he said like we give a input, say voice signal, and we are on the transcription out of it. Okay, so these boxes are actually the neural networks. We give input and we get the output. And what these neural networks are, we'll see. Like what type of networks we use based on the output. Like image we give it output is text captions. Game state we give, and the next move what we have to do in that game state. So this is all are the neural networks. Then he says the how neural networks are developed. What is the idea, thought process behind it? And actually, student, that all they actually originated from our brain cells. Like they studied brain cells so much, then they tried to create a neuron, and from the neuron a perceptron, and from perceptron this he escaped. He was no, yeah, 1800. Brain is a mass of neuron. Many neurons connecting to each neuron. Each neuron connects out to many neurons. This is what happens in the neural networks also. Okay, so where yeah, this is all we are going to see. Uh, this is a part of our this thing. This is Hebbian learning. I've not gone through all these. I was just going through the introductory class. So in introductory, he was just able to say what we are going to learn. Okay. Now I'll go through this particular thing. He covered all these things in his second lecture. Okay. So far, I don't know. I just went through the introductory phase. In fact, it was good for me to go through so that I know what I'm going to learn in this particular subject. Does it make any sense? I was able to convey, uh, uh, or okay. So my basics are clear. Like in the sense ki, we are going to see the MLP, we are going to CNN, we are going to see RNN, and two kinds of generative networks. These five things we are going to study in this particular subject. Huh? That's it. Okay. So I'll study the next one, and then Friday, I think I'll be able to take a complete lecture of what he wants to teach, um, or at least one particular, maybe algorithm or this thing network. Huh? What? Uh-huh. In fact, yeah, what I was thinking, I'll go what video lectures he has prepared now. If we go video by video or recordings by recordings, then we'll be able to comprehend it in a better way. What do you say? Let's call it a day. Huh? Hope. In fact, yes, it was taken very nicely. The question number one, na, like you prepared all those this thing. matlab, You tried to figure out show how the actually different shades work. Uh, since I was also associated with a lot of satellite imageries and all, so I know about the grayscale images. I know about how the pixel works. So it was nice. No, question one you taught na it was I got it very nicely. It was very well conveyed. Okay, that's great. That's great. Okay, okay. Yeah. And in fact, in this week there were only two classes. Na? Like one was taken by Veena, I believe. Okay. Uh-huh. No issues, no issues. Like we all have certain problems. Like that I was traveling day before, na? So I could not attend Veena's lecture. I'll just see. I'll just see. In fact, I'm also transitioning from military to corporate now, so I have to prepare my resume. That I'm in that phase also. Yeah.